the evaporating dish. We are using a Bunsen burner. We are going to heat up the evaporating dish to get a fixed mass, because if there is any extra volatile compound or moisture on the evaporating dish, it's not going to weigh the same as if it was completely clean and dry. So in order to remove anything excess from the evaporating dish, we are going to fire the evaporating dish on Bunsen burner. So I'm going to turn on the Bunsen burner first. On the flame, you have the darker and lighter blue color of the coals. Now you have perfect flame. So you are going to use a crucible tongue, hold your evaporating dish over the flame. Try to heat it up to evaporate any water that is in the evaporating dish. This container dried. We haven't used them for a long time. I just want to make sure to show you the technique and how to use this. So when it's done, when I heat it long enough that the water evaporated, now I have to place it on the surface in order to get the evaporating dish cool down to room temperature. So I'm going to leave it on a wire gauze to allow it to cool down before I can measure the mass. Okay? So I'm going to let it cool down before I measure the mass. I don't need the flame for a while, so I'm going to turn off the Bunsen burner. When I need about 0.5 grams of zinc. While it's cooling off, I'm measuring the 0.5 grams, and I will be using it soon. Press the tear button to tear to get the mass of the weighing paper 0. Then I can add the 0.5 grams. Okay. The mass is 0.500. It does fluctuate, but the most stable number is a 0.500. It goes from 0.499 to 0.500. And since the report, the data sheet asks for the mass of the crucible and then mass of the crucible with the evaporating dish and the zinc, we are going to follow that format. So don't have to figure out those numbers and change them. So mass of the empty evaporating dish. Before I place that, I'm just going to make sure it's 0 again. Place the evaporating dish. Record the mass. The mass for evaporating dish is 40.259. 40.259, and that is for A. I'm going to add 0.5 grams of zinc. B is 40.759 grams. Then we have mass of the iodine. Because it's a test tube, I'm going to place the test tube on the inside a beaker to measure the mass. So I don't have to lay it down, even though it's stoppered already, but still it's the correct way. If you have a test tube, it's better to have a container to place the test tube in, but you don't need the mass of the beaker, so you just leave the test tube inside a beaker. So we have 12.172. 0.72, and that is C. Okay, so 12.172 gram, that is the mass for stopper test tube. We are going to take the evaporating dish to fume hood. We add water and the acetic acid. So we place the evaporating dish inside the fume hood. We add 5 milliliters of deionized water. 3 drops of 6 molar acetic acid following the procedure. And I add the iodine to the evaporating dish. So I have the evaporating dish with the zinc and iodine is reacting. See that iodine has dissolved and slowly is going to react with the zinc and produces zinc iodide. How do I know the reaction is complete or I can stop? I have to make sure that iodine, the way the experiment was designed, iodine is the limiting reactant, zinc is the excess compound. So we should have excess amount of the zinc left over, and all of the iodine needs to be consumed. One evidence for iodine to be consumed entirely is if the yellow color goes away and it changes to clear color. So until the yellow color is in, we are not sure that there is still some leftover of the iodine. So it's going to get more brown before it gets colorless because the iodine that is here now is reacting. So it's dark color. I'm going to leave it in the fume hood and I have to mix it. I have to make sure that the reaction is complete and enhanced by mixing it to make it faster. And sometimes it's just the matter of time, how long it takes for this reaction to take place. The reaction must be done in the fume hood because iodine is toxic and we cannot have it outside of the fume hood. I'm going to leave this in the fume hood and you can go ahead and measure mass of the empty test tube. I placed the empty test tube on the balance on the scale 11.727, and that goes for D. So we have the mass of the iodine to begin to start for starting a reaction. We have the mass of the zinc that we started the reaction with, and we add the water, we add the acetic acid, the reaction is going on. It might take 10 to 15 minutes. The dark color has to disappear and it should go to colorless solution. If it's colorless, completely colorless, that is the ideal. That is ideal. Okay. For the step 12 of this experiment is asking me to decant it into another to a beaker. I have extra evaporating dish and I'm going to directly, because then it needs to be transferred to evaporating dish. So I'm just going to get the mass of the evaporating dish and fire the second evaporating dish. So when I'm decanting, I can decant directly into evaporating dish. I'm going to fire the second evaporating dish while we are waiting for yellow color to disappear or for iodine to react with the zinc completely. So I can actually use the time. and prepare equipment and chemicals for part 2 of the experiment. I hope you understand the firing part, the firing of evaporating dish, just to remove anything that is volatile, anything that is going to affect the mass later, because if we don't do that, and you see this brown spots here, if the mass is not stable, if let's say you have a paper there, you measure the mass later on after you heat up this for a long time, is going to burn the paper, and the mass gets down lower, and it's going to cause error, experimental error. Okay, it's heated. We wait for it to cool down to room temperature. So while we are waiting for evaporating dish to cool down, we can come back here and make sure that we mix the zinc with iodine, trying to get it to react faster. So it's very dark color now, and this dark color should disappear. It should get very light for us to make sure that the reaction is complete. For constant mixing, it's going to help the reaction to take place faster, but the time is a little bit more significant, so we have to allow time for the reaction. So mixing is a factor, but time is the primary factor for the reaction to take place. So the evaporating dish that we have here is cooled down to room temperature. I can bring to my hand like very close to it, and it's not. I don't want to touch it because I don't want to leave any residue of oil on it from my hand. So we can make this 0, and the balance has to be here. Make it 0, and after it's 0, I place the evaporating dish. Record the mass. This is for part 2A.
Should I move or?
45981 grams. So this is the mass for evaporating dish for part 2 of the experiment. What's time now? Time for checking on the zinc iodide reaction. All the iodine dissolved, but not reacted yet, is reacting. Gonna leave it here. Go and do another part of the experiment because it takes more time for this reaction. I need to evaporate the liquid. When we get the solution contains zinc iodide. The solution contains zinc iodide, and the solid that is left in the evaporating dish is going to be excess of zinc. The solution portion needs to be evaporated. The solvent evaporates, so what is left would be powder, like a white powder of zinc iodide. That is the product that we are going to recover for part 2 of the experiment. And the zinc that is left over, we are going to dry it using heating lamp and measure the mass again in order to find how much of zinc was left as unreacted zinc. So I have my Bunsen burner set up. To set up the Bunsen burner, I use an iron ring here to support the wire gauze, because later on I'm going to place my evaporating dish on the wire gauze. So there's something to support it, because I cannot depend on this. It's more safer if I'm using a wire gauze, or sometimes we could use like clay, a triangle is another equipment that we could use, but wire gauze is more secure. It's important for us to know the height of the flame and the height or the level of the iron ring. If I leave the iron ring all the way up here and the flame is all the way down, it's going to take much longer time for liquid to evaporate, for the solvent to evaporate. So I try to adjust the height of the flame as like a 2 inches. The iron ring, it should be about 2 inches higher than, the base of the flame or tip of the Bunsen burner cylinder. So that's how the Bunsen burner is set up when you are using the wire gauze. Sometimes you make like hot water bath, like we did for experiment 1 for boiling point. Sometimes you have to heat up any container supporting the wire gauze, so you know how to set up Bunsen burner for heating up. The other equipment that we are going to use today is the heating lamp. The heating lamp is just a heating lamp. It generates lots of heat that it can dry and evaporate the water or moisture from our product. So I have the heating lamp also ready to go here. When we have when we get the zinc separated from the solution by decanting or filtration, we are going to place it underneath the heating lamp and evaporate it. To clean this so it doesn't get stuck to the bottom of the evaporating dish before I use it. So my equipments are ready for the next step, but I need to check and make sure the chemical reaction is taking place. This is a long reaction. It takes very long time. It's a slow reaction because it's just the aqueous solution. But the good thing is that it works, and it has worked in the past. If we put excess amount of the zinc, it will react with all of the iodine, and the reaction will be complete. With the evidence that the color of iodine disappears, that means all iodine has been used. And at least hope that is happening is much lighter yellow color, lighter brown color. Hoping that this will happen. So it means the reaction is working. And this is working. I collected some drops of the solution here. by placing my stirring rod in there. So I'm going to have to transfer, because otherwise I would be losing the product. Adding some DI water, and the brown color is gone, and we have a light yellow color here. Okay. Very light yellow color. For second part of the experiment, or to separate the zinc from the excess zinc or unreacted zinc from zinc iodide, I'm going to decant the solution portion of it into second evaporating dish. We have the mass of this already recorded for you. So I'm going to decant this liquid. Decanting, meaning you pour off the liquid without getting any solid, okay? Without getting any solid into the receiving container, which in this case is my second evaporating dish. I'm adding more water and washing it. Just want to make sure that there is no leftover of the salt with the zinc. And make sure all the liquid is transferred without getting any solid. And I wash the zinc with DI water. Okay, when you get to read this experiment before you actually watch the video, you know the next step is for me to get the zinc or excess of zinc dried. So when it's dry, I can measure the mass. To dry the zinc, we are using heating lamp. So I'm placing my evaporating dish under the heating lamp here. Going to turn on the heating lamp and place the evaporating dish under the heating lamp until it's dry. When it's dry, when I try to move the zinc, the zinc particle is going to move around. When it's wet, the zinc particles are kind of clumped together and they are not moving around. That is the last step for part one of the experiment, because we want to get the mass of the unreacted zinc. So we are waiting for that. And while we are waiting for that one, I'm going to go ahead and start part two of the experiment. In part two of the experiment, we need the mass of empty evaporating dish, which I have it as a part 2A, 45.981. That's the mass of empty evaporating dish. We get the solution into the evaporating dish, and with the solution that we have in the evaporating dish, it needs to be vaporized. The solvent needs to be vaporized. So this solution is solution of zinc iodide. When we evaporate the water part, the solvent, we are going to end up with the powder or solid zinc iodide. The heating must be gentle. We don't want to get any of the water, the solution which contains salt, to spatter out of the evaporating dish. So I monitor the boiling. When I monitor the boiling part of this, is going to show me, if it's like gentle boiling, I'm fine with it. If it's not gentle boiling, if it's like boiling very harsh and big bubbles, the chance for spattering of the solution out of the container, I'm going to remove the flame and remove it and move it back and forth in order to give like gentle boiling. So I do need gentle boiling for this evaporation, because I don't want to lose any of the product. So we have two procedures taking place, two steps of the procedure taking place at once. The drying of the zinc, unreacted zinc. So we want to know how much of the zinc was reacted. We have initial mass for initial mass for the zinc, whatever we start with, 0.5 grams. And if we get the mass of unreacted, we subtract from initial mass, and this way we can get the mass of reacted. We also have the mass for reacted iodine because we have the mass before and after for the test tube when we had the iodine and we had empty mass for empty test tube container. So if you have the mass of the elements, we can calculate the empirical formula using periodic table, changing the mass of each element to moles, and then dividing by a smaller number to get the molar, a lowest ratio. And if it's not whole number, we have to treat in order to get whole number. So if you get like a 0.5, you multiply by 2 to get a whole number. If you get 0.33 for one of them, you multiply by 3 to get the whole number. Well, the numbers are not going to be perfect numbers because these are not made up numbers. These are the real numbers that is called actual. You have actual numbers and then you have theoretical values. The difference between actual and theoretical values in experiment is called experimental error or percent error. Some range of percent error is acceptable in a experiment. Okay, the zinc, perfect. Unreacted zinc is, I'm going to show it to you actually what I mean by, you see, the zinc is moving around. And if it's moving around, that means it's not moist, because when it was moist, it was stuck to the wall because it was moist. Now it's moving around and it shows that it is dry. So I'm going to turn off the heating lamp at this point. Wait for the for evaporating dish to cool down to room temperature, and weigh the container, which is the evaporating plus unreacted zinc. Also, I want to show you what I mean by the gentle boiling. If you can see the boiling there, is the gentle boiling. Is not crazy, is not spagging, and is not moving the chemicals out. You can measure the mass of the zinc. The balance needs to be paired. The unreacted zinc. This is for part 1 of the experiment. And it's going to go to part E. Part 1, letter E. And the mass is 40.642. 40.642 grams. This is the mass of, you can use this to find the mass of unreacted zinc. Almost there. And it just needs maybe like a couple more minutes to dry up completely. When it gets low, drying out, it happens like quickly because that's very concentrated at this point, because you have all of your zinc iodide in that small volume of solvent. So it's very concentrated. It's a thick solution at this point. Okay, see it for yourself. Almost there. So we turn off the Bunsen burner. We leave the evaporating dish. to cool down to room temperature before we measure the mass. When you are measuring the mass, you should always measure the mass at room temperature. So to be consistent, we have to measure the mass at room temperature. So I'm leaving on the wire gauze, wait until it cools down to room temperature. Same thing again, I'm going to close my hand. If I don't feel the radiation of the heat, it's good enough for me to measure, but I still feel it would be a while because it's dry. There is no liquid. If we had like a hot water, because of the specific heat that water has, it takes longer for it to lose the heat. But for solid clay like this, with the it doesn't have a much. It doesn't have a high specific heat. As a result, it can actually change the temperature. The temperature of the object itself is going to go up and down quickly, so it can reach the room temperature quick. It doesn't take that long. I guess you learn about that in the general chemistry or beginning of general chemistry too. Okay, we measure the mass of evaporating dish with the zinc iodide, and that goes into part 2. That goes into part 2 plus dry B, which is the dry product. So part 2B. And the mass is 46.508. 46.50 is changing, so 8. And that is gram. That's for part B. Everything else, you do have like mass of the zinc iodide, which you actually need to do the calculation based on the information that you have. But the information to be collected in the lab are those numbers that I already, also I said it, so you can record those numbers. And also the description of the appearance, just because it's a white powder I showed you, so you can record your observation based